Hello, how are you all? Welcome to Maths Companion. I am Ramesh. Have you studied the previous part? Have you done the homeworks? Let us remember what we have learned in the last video. We have learned nth term equal to first term plus n minus 1 times common difference, or xn equal to dn plus f minus d. We have also learned the algebraic form of any arithmetic sequence is of the form xn equal to an plus b, where a and b are fixed numbers. We have also seen that the coefficient of n is the common difference and a plus b gives the first term. Then there were two homeworks. Let us check the answers. The first one was prove that the arithmetic sequence 5, 8, 11, etc. contains no perfect squares. What is the first term here? 5. And what is the common difference? 3. Let us find the algebraic expression xn equal to dn plus f minus d. Substituting the values, we get 3n plus 5 minus 3. And 5 minus 3 is 2. So this can be written as 3n plus 2. What does it mean? Nth term is of the form 3n plus 2, means a multiple of 3 plus 2. 3n means 3 into 1, 3 into 2, 3 into 3, etc. They are all multiples of 3. So 3n plus 2 means a multiple of 3 plus 2. That means every term of this sequence is of the form 3n plus 2 or a multiple of 3 plus 2. Let us look at the terms. First term is 5, that is 3 plus 2. Second term is 8, that is 6 plus 2. Third term is 11, that is 9 plus 2. Now we have to prove that this sequence contains no perfect squares. So we have to take perfect squares and we have to prove that they are not of this form. That is, no square is of the form 3n plus 2. Now when we take all the numbers, it is either a multiple of 3 or a multiple of 3 plus 1 or a multiple of 3 plus 2. Let us check. When you take 1, that is 3 into 0 plus 1. When you take 2, that is 3 into 0 plus 2. When you take 3, that is 3 into 1. Now when you take 4, that is 3 plus 1. When you take 5, that is 3 plus 2. When you take 6, that is 3 into 2. So all the numbers can be expressed either as a multiple of 3 or a multiple of 3 plus 1 or a multiple of 3 plus 2. That is of the form 3n or 3n plus 1 or 3n plus 2. Now let us take each of these and take the square. Since 3n is a multiple of 3, its square is also a multiple of 3. That means all those numbers which are multiples of 3, their squares are also multiples of 3. So they are not of the form 3n plus 2. Now let us take all those numbers which are of the form 3n plus 1 and let us find out the square. The square is first term square plus 2 into first term into second term plus second term square. We know 3n is a multiple of 3. So 3n square is also a multiple of 3. 2 into 3n into 1 is a multiple of 3. And we know when two multiples of 3 are added, it is again a multiple of 3. So up to this is a multiple of 3. Then plus 1 square means 1. So we can say this is equal to a multiple of 3 plus 1. That means it is not of the form 3n plus 2, but it is of the form 3n plus 1. So it's also not a term of this sequence. Now let us take all the numbers of the form 3n plus 2. Let us take the square. First term square, 2 into first term into second term plus second term square. Now 3n is a multiple of 3. So the square is also a multiple of 3. 2 into 3n into 2. That is also a multiple of 3. And 2 square is 4. So we can write multiple of 3 plus multiple of 3 plus 4. Now 4 can be written as 3 plus 1. So this can be written as multiple of 3 plus multiple of 3 plus 3 plus 1. Now this is a multiple of 3, this is again multiple of 3, 3 is also a multiple of 3. Adding all these 3 together, we get another multiple of 3. So it can be written as multiple of 3 plus this last one. So the square of all the numbers of the form 3n plus 2 is of the form 3n plus 1 or multiple of 3 plus 1. That means that is also not a term of this sequence, or we can say no square is of the form 3n plus 2. Therefore, no perfect square is in this sequence. Now the next problem, write the whole numbers in the arithmetic sequence 11 by 8, 14 by 8, 17 by 8, etc. Do they form an arithmetic sequence? What is the first term here? 11 by 8. Common difference, 14 by 8 minus 11 by 8. That is 3 by 8. Now let us find the nth term, dn plus f minus d. Giving the values, we get 3 by 8n plus 11 by 8 minus 3 by 8. What is 11 by 8 minus 3 by 8? The denominators are same. Let us subtract the numerators. 11 minus 3 is 8 and 8 by 8 is 1. So we can write it as 3 by 8n plus 1. Now this can be written as 3n by 8 plus 1. When will this become a whole number? 1 is a whole number. So this is a whole number when 3n by 8 is a whole number. Now when is 3n by 8 a whole number? The numerator should be a multiple of 8. Then only this 8 get cancelled. When is the numerator 3n a multiple of 8? 3 is not a multiple of 8. So n should be a multiple of 8. That means this is a whole number when n is a multiple of 8, which is the first multiple of 8, 8, right? So we get the first whole number when we give the value of n as 8. Let us give the value of n as 8. So 8 and 8 get cancels and we get 3 plus 1, that is 4. So the first term of the sequence is 4. The next term is obtained when the value of n is given as the next multiple of 8, that is 16. So when we give n equal to 16, 2 8s are 16. So we get 3 into 2 plus 1, that is 7. So that is the second term. And the third term is obtained when we give n equal to third multiple of 8, that is 24. So when we give n equal to 24, 3 8s are 24. So we get 3 into 3 plus 1, that is 10. And we can see one thing, that when we give n equal to it, that is actually the 8th term of the sequence. And the second whole number is when n is 16, means the 16th term of the sequence. And the third term is when n is 24, that means it is the 24th term of the sequence. Now what is the newly obtained sequence? That is the sequence of whole numbers 4, 7, 10, etc. And we can see 4 plus 3 is 7, 7 plus 3 is 10. So it is an arithmetic sequence. We have learned arithmetic sequences and their algebraic expression. Today, let us find the sum of arithmetic sequences and observe how they are related to the terms. Let us take 3 consecutive natural numbers and find the sum. The first 3 consecutive natural numbers are 1, 2 and 3. Their sum is 6. Now take next 3 consecutive natural numbers 2, 3, 4. What is the sum? 9. Now 3 plus 4 plus 5 equal to 12. Now look at the middle number and the sum. Are they connected in any way? This is 3 into 2. 9 is 3 into 3. 12 is 3 into 4. So what did we see? Sum is 3 times the middle number. Is it always true? Let us take some other 3 consecutive natural numbers. 21 plus 22 plus 23 equal to 66. What is 3 into 22? That is also 66. So here also it is true. Is it always true? How can we check? Let us use algebra. Suppose the middle number is x. Then what is the next number? When it is 22, the next number is 23. We got it by adding 1. So if the middle number is x, the next number will be x plus 1. And in the same way, the previous number is x minus 1. So let us add all these three together. X minus 1 plus x plus 1. Minus 1 and plus 1 get cancelled and we get x plus x that is equal to 3x. Look at the middle term x and the sum is equal to 3x. That means sum of three consecutive natural numbers is always 3 times the middle number. When you give different values for x, you will get all the 3 natural numbers. So this is always true. Now instead of natural numbers, let us take 3 consecutive odd numbers. 1 plus 3 plus 5 is 9. 3 plus 5 plus 7 is 15. 5 plus 7 plus 9 is 21. Can you see the same relationship here also? 9 is 3 into 3. 15 is 3 into 5. And 21 is 3 into 7. Let us take some other 3 consecutive odd numbers. 21 plus 23 plus 25 equal to 69. What is 3 into 23? That is also 69. Now let us generalize using algebra. Suppose the middle number is x. What is the next number? X plus 2, right? And what is the previous number? X minus 2. Let us add it together. X minus 2 plus x plus 2. Minus 2 and plus 2 get cancelled. X plus x is 3x. That is, sum of 3 consecutive odd numbers is always 3 times the middle number. Now let us take 3 consecutive even numbers. 2 plus 4 plus 6 is 12. 4 plus 6 plus 8 is 18. 6 plus 8 plus 10 is 24. Can you see the same relationship here? 12 is 3 times 4. 18 is 3 times 6. 24 is 3 times 8. Let us take some other 3 consecutive even numbers. 22 plus 24 plus 26 equal to 72. What is 3 into 24? That's also 72. Now let us check using algebra. Suppose the middle term is x. What is the next term? X plus 2. What is the previous term? X minus 2, right? Now let us add x minus 2 plus x plus 2 equal to 3x. That means sum of 3 consecutive even numbers is always 3 times the middle number. Natural numbers, odd numbers, even numbers, all these are special cases of arithmetic sequences. So let us check an arithmetic sequence and check whether this property holds there or not. Let us take an arithmetic sequence. Let us take sum of first 3 terms. 2 plus 7 plus 12 is 21. 7 plus 12 plus 17 is 36. 12 plus 17 plus 22 is 51. Can you see the relationship here also? 21 is 3 into 7. 36 is 3 into 12. 51 is 3 into 17. Let us check using algebra. Suppose the middle term is x. What is the next term? We know by adding common difference to a term, we get the next term. So the next term is x plus d. And subtracting the common difference from a term, we get the previous term. So the previous term is x minus d. So we can take 3 consecutive terms of an arithmetic sequence as x minus d, x plus d. Let us add it together. Minus d and plus d get cancels. X plus x is 3x. What does it mean? So we can say The sum of any three consecutive terms of an arithmetic sequence is 3 times the middle term. Now suppose the three terms are x, y, z. Then we can say x plus y plus z equal to 3 times the middle term, that is 3y. Now let me take y on the other side. So I can write x plus z equal to 3y minus y. What is 3y minus y? 2y, right? Take 2 on the other side. So I can write y equal to x plus z by 2. What does it mean? Y, that is the middle term, equal to x plus z by 2. That is middle term equal to half the sum of the other two. Or we can say, in any three consecutive terms of an arithmetic sequence, the middle term is half the sum of the first and last. Or we can say, if x, y, z are three consecutive terms of an arithmetic sequence, then y equal to x plus z by 2. Now suppose sum of the first three terms of an arithmetic sequence is 12. What is the second term? We know second term is the middle term. Here sum of the terms is 12. We know sum of the terms is 3 times middle term. So second term equal to 4, because 3 into 4 is 12. Now second term of an arithmetic sequence is 10. What is the sum of the first three terms? We know sum of the terms equal to 3 times the middle term. So sum of the term is 3 into 10 or 30. Now instead of 3 terms, let us take 5 consecutive terms and let us find the sum. Suppose x is the middle term. Then the next term of the arithmetic sequence can be written as x plus d, where d is the common difference. And to get the next term, you have to add common difference once again, that is x plus 2d. Now to get the term before x, we have to subtract common difference, that is x minus d. To get the term before x minus d, we have to subtract d again, that is x minus 2d. Now let us add all these together. Minus 2d plus 2d, it's 0. Minus d plus d, that is again 0. What is remaining now? X plus x plus x plus x plus x, that is 5x. What does it mean? Sum of 5 consecutive terms of any arithmetic sequence is 5 times the middle term. Now let us take 7 consecutive terms of an arithmetic sequence. As in the previous case, let us take the middle term as x. Then the term after that is x plus d, and after that it is x plus 2d, and after that it is x plus 3d. We know if we are taking 7 terms, there are 3 terms after the middle term and there are 3 terms before the middle term. So the term before x is x minus d, and before it is x minus 2d, and before it is x minus 3d. As in the previous case, when we add minus 3d and plus 3d becomes 0, minus 2d and plus 2d becomes 0, minus d plus d becomes 0. Now there are 7 terms, and in each there is an x. Adding together we will get 7x. Now without checking, can you say what is the sum of 9 consecutive terms of an arithmetic sequence? It is 9 times middle term, because when we take middle term, there will be x plus d, x plus 2d, x plus 3d and x plus 4d on the right side, and x minus d, x minus 2d, x minus 3d and x minus 4d on the left side. And cancelling and adding, we will get 9x. So what can we generalize here? If n is an odd number, then sum of n consecutive terms of an arithmetic sequence is n times the middle term. Or we can say middle term equal to sum of the terms by number of terms. Whenever n is an odd number, middle term is equal to sum of the terms divided by number of terms. So far we have discussed odd number of terms. Now let us take even number of terms. Let us consider the sequence 5, 8, 11, 14, etc. Let us take the 4 terms. Now take first term and fourth term, that is 5 and 14. The sum is 19. Now take the second term and third term, that is again 19. So what can we say now? First term plus fourth term equal to second term plus third term. Look at the positions. 1 plus 4 is 5. 2 plus 3 is 5. So what did we see now? If the sum of the positions are equal, sum of the terms are also equal. First term plus fourth term, second term plus third term are equal. Is it always true? Let us take 6 terms of the same sequence and check. First term plus sixth term is 5 plus 20, that is 25. Second term plus fifth term, that is 8 plus 17, and that is equal to 25. Third term plus fourth term, that is 11 plus 14, that is also 25. So we can say first term plus sixth term equal to second term plus fifth term, that is equal to third term plus fourth term. Look at the positions. 1 plus 6 equal to 7, 2 plus 5 equal to 7, 3 plus 4 equal to 7. So everywhere sum of the positions are equal, and you can see some of the terms are also equal. Let us take 8 terms and check. First term plus 8th term is 5 plus 26, that is 31. Second term plus 7th term is 8 plus 23, that is also 31. Third term plus 6th term, that is also equal to 31. Fourth term plus 5th term, that is also equal to 31. So we can say first term plus 8th term equal to second term plus 7th term equal to third term plus 6th term equal to fourth term plus 5th term. Look at the positions. 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9. Some of the positions are equal, some of the terms are also equal. Is it always true? Let us check using algebra. Let me take 10 terms. First term plus 10th term. Let the first term be f. And we know 10th term is first term plus 9 times d. So we can write first term as f and 10th term as f plus 9d. Adding together we get 2f plus 9d. Now second term plus 9th term. Second term is f plus d and 9th term is f plus 8d. Adding together we get 2f plus 9d again. Now third term plus 8th term. Third term is f plus 2d and 8th term is f plus 7d. Adding together we get 2f plus 9d again. Fourth term plus 7th term. Fourth term is f plus 3d and 7th term is f plus 6d. Adding together we get 2f plus 9d again. Now fifth term plus sixth term. Fifth term is f plus 4d and sixth term is f plus 5d. Adding together we get 2f plus 9d again. Look at the positions. 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, 4 plus 7 is 11, 5 plus 6 is also 11. So when the sum of the positions are equal, sum of the terms are also equal. Now what happens when we take odd number of terms? Let me take 9 terms now. First term plus 9th term equal to f plus 8d. That is 2f plus 8d. Second term plus 8th term, that is f plus d plus f plus 7d. Adding together we get 2f plus 8d again. Third term plus 7th term, that is f plus 2d plus f plus 6d. Adding together we get 2f plus 8d again. Fourth term plus 6th term, f plus 3d plus f plus 5d. Adding together we get 2f plus 8d again. Now there is only one term remaining, the fifth term. When the number of terms is odd, there is a term at the middle. How can I pair it? fifth term plus fifth term. That is f plus 4d plus f plus 4d. That is equal to 2f plus 8d again. Once again look at the positions. 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10, 5 plus 5 is again 10. So it's very clear that when the sum of the positions are equal, sum of the terms are also equal. Or we can say, in an arithmetic sequence, if the sum of the positions of two pairs of terms are equal, then the sums of the pairs of the terms are also equal. Now let us take an example. The first term of an arithmetic sequence is 5 and the sum of the first 6 terms is 105. Find the sequence. Given that the first term is 5 and sum of the first 6 terms equal to 105. When we take 6 terms, we can make 3 pairs. First term plus 6th term, second term plus 4th term. When we take 6 terms, we can make 3 pairs. First term plus 6th term, second term plus 5th term, third term plus 4th term. All these sums are equal because their position sums are equal. Here first term is given. Let me take first term plus 6th term. Since there are 3 pairs, the sum of each pair is equal to 105 divided by 3. That is equal to 35. That means x1 plus x6 equal to 35, x2 plus x5 equal to 35 and x3 plus x4 is also 35. Here we know the first term. So 6th term equal to 35 minus 5. That is equal to 30. Now we got 2 terms, first term and 6th term. We know common difference is term difference by position difference. That is 6th term minus first term by 6 minus 1. Here 6th term is 30 and first term is 5. So we can write 30 minus 5 by 5. That's equal to 25 by 5 or 5. So the common difference is 5 and first term is 5. So we can easily write the sequence as 5, 10, 15, etc. You can check whether your answer is right or wrong by taking 6 terms and finding the sum and verifying whether it is 105 or not. Now let us do some problems from page number 28. First question. Write 3 arithmetic sequences with 30 as the sum of the first 5 terms. Given that the sum is 30 and number of terms is 5, we know middle term equal to sum of the terms by number of terms. When we take first 5 terms, which is the middle term, third term, right? So we can write third term equal to 30 by 5 or 6. Now we got the third term. If you subtract common difference from third term, you will get second term. And if you subtract the common difference again, you will get the first term. You can take different values for common difference and you will get a lot of arithmetic sequences. Let me take the common difference as 1. Then second term is 5 and first term is 4. So we can write the sequence as 4, 5, 6, 7, 8. Now when you take the common difference as 2, second term is 4 and first term is 2. So the sequence is 2, 4, 6, 8, 10. Now when you take common difference 3, second term is 3 and first term is 0. So you can write the sequence as 0, 3, 6, 9, 12. Just like this, by giving different values for the common difference, you can make a lot of sequences. Second problem, the first term of an arithmetic sequence is 1 and the sum of the first 4 terms is 100. Find the first 4 terms. Given that sum of first 4 terms is 100, since there are 4 terms, we can make 2 pairs and the sum of each pair is 50. That is first term plus 4th term is 50 and second term plus third term is also 50. And we have given that first term is 1. Therefore fourth term is 50 minus 1 or 49. Now we have got two terms. First term is 1 and fourth term is 49. We know the common difference is term difference by position difference. That is fourth term minus first term by 4 minus 1. Here fourth term is 49 and first term is 1. So we can write it as 49 minus 1 by 3. And that is 48 by 3 or 16. So the common difference is 16. Given that first term is 1, so the second term is 1 plus 16, that is 17, and third term is 17 plus 16, that is 33, and fourth term is 49. Now the third problem. Prove that for any 4 consecutive terms of an arithmetic sequence, the sum of the two terms on the two ends and the sum of the two terms in the middle are the same. Let the 4 terms of an arithmetic sequence be x, x plus d, x plus 2d, and x plus 3d. If x is the first term and d is the common difference, second term is first term plus common difference or x plus d. Third term is second term plus common difference or x plus 2d. Fourth term is third term plus common difference, that is x plus 3d. Now let us add the first term and last term or sum of the two terms on the two ends, that is x plus 3d. Adding we will get 2x plus 3d. Now let us add the terms at the middle, that is x plus d plus x plus 2d. Adding we get 2x plus 3d again. So we can see they are equal. So the sum of the two terms on the two ends and the sum of the two terms in the middle are the same. Now fourth problem, write 4 arithmetic sequences with 100 as the sum of the first 4 terms. Given that sum of the first 4 terms is 100, that is first term plus second term plus third term plus fourth term is 100. Since there are 4 terms, we can make 2 pairs. That is first term plus last term is 50 and second term plus third term is 50. Now we know second term plus third term is 50. Let us take two numbers whose sum is 50. Let me take 24 and 26. We know 24 plus 26 is 50. So let me take second term as 24 and third term as 26. Then what is the common difference? 2, right? Now to get the first term, subtract common difference from the second term, that is 24 minus 2 or 22. And to get the fourth term, add common difference to the third term, that is 26 plus 2, that is 28. So the 4 terms are 22, 24, 26, 28. Now let us take another combination. We know 23 plus 27 is also 50. Then the common difference is 4. So the first term is 19, then second term is 23, third term is 27, and last term is 31. Now we know 22 plus 28 is also 50. So let us take 22 as the second term and 28 as the third term. Then the common difference is 6. So the first term is 16, second term is 22, third term is 28, and last term is 34. Now we know 21 plus 29 is also 50. Then the common difference is 8. So the first term is 13, second term is 21, third term is 29, and fourth term is 37. By taking a different combination of numbers whose sum is 50, we can find different sequences. Now the fifth problem. Write the first 3 terms of each of the arithmetic sequences described below. First term 30, the sum of the first 3 terms is 300. First term 30, sum of the first 4 terms is 300. First term 30, the sum of the first 5 terms is 300. First term 30, the sum of the first 6 terms is 300. Let me take the first part. First term 30, the sum of the first 3 terms is 300. When we take 3 terms, the sum is 3 times the middle term. Here second term is the middle term. So we can say second term equal to 300 by 3 or 100. Now the first term is 30, second term is 100. So the common difference is 70 and therefore the third term is 170. And the second part, first term 30, sum of the first 4 terms 300. When we take 4 terms, we can make 2 pairs and the sum of each pair is 150. That is, first term plus last term is 150 and second term plus third term is also 150. Given that first term is 30, so fourth term equal to 150 minus 30, that is 120. Now we know the common difference is term difference by position difference, that is x4 minus x1 by 4 minus 1. That is 120 minus 30 by 3 or 90 by 3. That is equal to 30. First term is 30, common difference is 30. So the 4 terms are 30, 60, 90 and 120. Now the third part, first term 30, sum of first 5 terms is 300. Here the middle term is third term. So third term equal to 300 by 5 or 60. Third term is 60, first term is 30. So the common difference is 60 minus 30 by 2. That is 30 by 2 or 15. First term is 30, common difference is 15. So the terms are 30, 45, 60, 75 and 90. Fourth part, first term 30, sum of first 6 terms 300. There are 6 terms, we can make 3 pairs and sum of each pair is 100. So we can say first term plus 6th term is 100, second term plus 5th term is also 100, third term plus 4th term is also 100. Given that first term is 30, therefore 6th term equal to 100 minus 30 or 70. Now common difference equal to 6th term minus first term by 6 minus 1. That is 70 minus 30 by 5 or 40 by 5 and that is equal to 8. First term is 30, common difference is 8. So the terms are 30, 38, 46, 54, 62 and 70. Now let us remember what we have learned today. The sum of any 3 consecutive terms of an arithmetic sequence is 3 times the middle term. Then we have learned in any 3 consecutive terms of an arithmetic sequence, the middle term is half the sum of the first and last. And we have seen if n is an odd number, then sum of n consecutive terms of an arithmetic sequence is n times the middle term, or middle term equal to sum of the terms by number of terms when the number of terms is odd. And lastly, we have seen in an arithmetic sequence, if the sums of positions of 2 pairs of terms are equal, then the sums of the pairs of the terms are also equal. Now you have 2 homeworks from page number 28. First one, the sum of the first 5 terms of an arithmetic sequence is 150 and the sum of the first 10 terms is 550. What is the third term of the sequence? What is the 8th term? What are the first 3 terms of the sequence? Second problem, the angles of a pentagon are in arithmetic sequence. Prove that its smallest angle is greater than 36 degrees. Do the homeworks, prepare your notes, study well, study regularly and stay safe. I'll be back with another video. Till then, bye.